Hi, good morning everyone. My name is Abhishek and I am the Chief Digital Officer for RGE Singapore. We are primarily in a very traditional industry around commodities and natural resources. Like Adrian mentioned, we are in the pulp and paper manufacturing business primarily, but we also deal with some other commodities like viscose fiber and palm oil. Now, because we are very much in the manufacturing business, we are in the process of undertaking digital transformation for our factories, and I would like to share some stories here about how we are going about doing that. So with that, let's look at the topic for the day, smart automation enabling the factory of the future for industrial business across Asia. Right? So before I get started, I'll just pick off what Adrian mentioned before he handed over the stage to me, and that is about factory of the future and how in the future everything is going to be fully automated based on AI and ML. And for those of you who've attended these AI conferences before, there's a very common story which goes around that there's a factory somewhere in Europe, an automotive factory which is 100% automated as we speak today, and there's only one person manning that factory, and he does so with a dog. The purpose of that man in that factory is to just keep the lights on, and the purpose of the dog is to keep company to that man. Right? It's a very common story which goes around some of these AI conferences nowadays where you talk about factory of the future or industrial automation. Having said that, it's not really very relevant to where we come from in this part of the world. And there are a couple of reasons why, and I would like to build the context before I present some of my slides going forward. In Asia, we are really not that pressed for labor cost, right? Most of our manufacturing happens in countries like Indonesia, Philippines, Malaysia, to a certain degree, of course, in China, Vietnam, and even a little extent in India. Like we had the earlier speaker talking about TVS Motors out of India, right? These are countries where labor can be relatively inexpensive, and the cost driver is, from labor perspective, is not the primary motivation for automation. Right? So for us, it's really not about driving the labor cost down or getting rid of people per se in a factory. For us, it's automation to bring predictability and productivity. Right? Productivity here does not mean productivity of people, but the productivity of the factory. And then, of course, quality. So as we go along, you will see that there are so many technologies that we talk about in the Industrial Revolution, the Industry 4.0. There are different technology terms which float around: smart factory, factory of the future, Industry 4.0, digital manufacturing, you name it, and there's a technical term for it nowadays, right? What I would like to highlight here, though, is for some of us who've been in the manufacturing business for the last 50 years, it's not about setting up the factory of the future. It's about taking our factories which have been around for the last 30 years or 40 years and making them smarter. And that actually is a whole different skill set. It's the difference between making a new building versus refurbishing an old one, right? You don't need the same skills for refurbishing an old building that you need for making a new building. And that's the same challenge we have in digital today. When we are talking about setting up a new factory, for example, right now we are in the process of setting up a new one in Brazil. There we have the option to choose all the latest technologies that you see on the screen today. We can buy the most expensive, most automated software, we can plug in the most interesting sensors, most relevant sensors, and we can really create a future factory. But what do we do about those 20-odd, 30-odd factories which we have been having for the last 50 years? How do we make them smart? And that's a whole different skill set. So for us, factory of the future, also known as smart manufacturing or digital enterprise, is really about convergence of two domains, the information technology and operational technology. And for those of you who are familiar with the manufacturing world, operational technology is probably a little older than information technology. So things like DCS, PLCs, SCADAs, they've existed for a lot longer than, say, smartphones and mobile and tablets. And the idea here is really to bring efficiency and predictability to operations so that you are able to reduce the potential for human errors. And there should be as little downtime as possible due to manual faults or due to incorrect measurements or due to incorrect configuration of the machine. So for us, the factory of the future, number one, whatever we do has to be very agile because it's all about business. And business is all about ROI. If you take too long to do something and you spend too much money before you start generating results, you will find that the business will lose patience. So agility for us is always number one in every initiative we do, including setting up the factory of the future. Then of course it's about automation, right? So we already have a fair bit of automation in our factories, and that comes from the operational technology world. We have DCS systems, we have PLCs, we have SCADAs, we have high-speed cameras which do quality checks, lab information management systems, and so on and so forth, right? So we've already had a fair degree of automation. What the new digital technologies are now allowing us to do is to extract more value from that automation. Of course, then it's about collaboration, innovation, bringing cloud into the picture, customer centricity, data-driven, and finally and most importantly, making it efficient. Everything is about getting maximum value from your setup, from your factory, from your hardware which you have installed in the factory. And that's a very important differentiation which I would like to make compared to some of the other speakers who I hear about. It's really not about replacing people with AI or replacing people with automation. In any manufacturing setup, in Asia specifically, people will always be a key part to all manufacturing operations. And the reason is because the infrastructure is so fragmented, and so are the factories, so are the surrounding functions around the factories, be it the suppliers, be it the logistics providers. So people will always have a very strong role to play in Asia for a very long time to come. What we can do is we can extract the maximum ROI from our hardware setup, which is all the equipment we have installed, be it the dryers, the PLCs, the machines, the paper cutting machines, the pulp making machines, the boilers, the digesters that we've got set up in the factories. We can drive them to the maximum possible limit of 24 hours a day, 365 days a year. And that's the ideal scenario of a smart factory for us. Once you have the smart factory, which we like to call site excellence, right? Which is one specific site operating at maximum possible efficiency, taking into account planned downtime. It then becomes about connecting the factories together. Because if you have different factories doing the same thing across different geographies, you can actually get what we call network efficiency. So you can connect one factory in Indonesia with a factory in Brazil or a factory in China, and if you are going to run low on raw material for a certain product in certain factory, you can communicate automatically with the other factories to try and bring out some efficiencies which come with creating such a network, right? So you try and achieve site excellence first, and once you've got the site excellence, then you do the connected factories to create network effect, which is then the network excellence. And this is exactly what we are now in the process of trying to achieve. Of course, like I started off by saying, that for us, a lot of challenge is about retrofitting our existing traditional factories and making them smarter. And one way to do that is to bring in sensors, be it temperature sensors, vibration sensors, flow meters, pressure meters, so on and so forth. I think earlier in the day during the presentation by Singapore Power, they spoke a lot about how they are managing electricity and how they are managing power with respect with the use of new smart sensors. And I think a lot of those use cases are applicable to any factory, any manufacturing outfit around the world, including us. So one of the examples that we are working on is what we call the smart sensor for vibration. So a lot of factories around the world, they have rotating equipment, and this rotating equipment can be pump, for example, and that pump usually has a certain vibration frequency. And when it's about to kind of break down, that frequency starts to show some deviation. Traditionally, you get people to go around, measure the frequency of these pumps, and they used to have handhelds in the early 2000s till about 2015. And now there are sensors which you can just plug on top of the pump, which will constantly monitor the vibration of the pump. And at any point when the vibration is changing frequency, it will automatically generate an alert. So this is a kind of Bluetooth sensor, which is a plug-on. And it's like a plug and play which you can just put on top of a motor or any rotating equipment. Now for people like us who are trying to retrofit some of the traditional factories, this kind of sensors are very, very important, because they achieve two very important criteria of creating a smart factory. Number one, they are less invasive, which means I don't need to rewire my infrastructure. It's a Bluetooth device, so I don't need to meddle with the wiring at all. All I need to do is just plug it on top. Number two, it brings very strong automation to something which is very basic and critical, because when a pump breaks down, it can actually shut down the entire production line. And depending on the criticality of the pump, the downtime can be pretty significant. So it achieves the second objective, which is predicting the downtime. And it does so in the non-invasive fashion. So for us, these kind of sensors are obviously very, very important. And we have plans to put pressure sensors, temperature sensors, vibration sensors all across our factories to try and make them as smart as possible. And some of the companies which are doing it, you can see on the screen, for example, ABB is already into the space, Yokogawa is already into the space, Emerson is already into the space, so Anderson Hauser is already working in the space. So there are dime a dozen companies which are already quite active in this scene, creating these sensors, and it has come down to a point that it's relatively easy to achieve this kind of IoT-based, sensor-based automation for traditional factories. Of course, once you start collecting all this data, you have to put it on a platform. You have to collect that data and you have to create a platform for analyzing that data. So this is where we talk about digital manufacturing platform, where we start collecting the data. And digital manufacturing platform is a multi-purpose platform with fundamental building blocks of infrastructure that allows unlimited applications to be built towards the objective of achieving operational excellence in the manufacturing process. Right? So eventually the goal is operational excellence. And operational excellence can come in two aspects of a factory. It can come in the maintenance side, which is the one in green color you see around predictive maintenance, or it can come in the production side of things, which means during the process of production, you should be able to tweak your parameters in a way which can lower the cost of your production to the maximum extent possible, right? So production use cases, maintenance use cases. Both these use cases can be delivered on top of a common platform. And the objective is to create that common platform so that you start capturing the data and you start building analytics on top of that. And this is how it will look like if you get it right. And we are, of course, in the process of building it. So we've got some part of it right. But we are still working on some of the other parts. So at the bottom, of course, you will have the automation, which is your connectivity to the devices, to your equipment, to your machinery, to your production plant, to your power plant, so on and so forth. It will be connected using the connectivity technologies, which at this point we prefer them to be wireless. We prefer Bluetooth, we prefer Wi-Fi compared to wired network, because of course wired network requires actual physical change of infrastructure within the factory, which for traditional factories is very, very I should say it's rather risky and should be avoided at all possible costs. Right? On top of that, once you have all these sensors, you start collecting the data, you build a data lake, and you start doing your big data analytics. And beyond that, once you've started creating that platform, you can create a whole host of apps. Each of these apps can be targeted around specific business problems with respect to either maintenance or production. So let's take an example of what we are doing so far. So in order for us to do all that, first and foremost, of course, we need to build a dashboard, right? We need to collect the data and we need to look at the data, what it means, where are the opportunities. So for us to collect that data, we traditionally, there is a software in the manufacturing world which is called a PI software. It's a historian. Its entire job is to collect data from the manufacturing equipment, from all the sensors which exist in the manufacturing world. So you collect that data and you put it on a analytics platform until you achieve an outcome towards common KPIs and benchmarking. So this is the kind of the architecture which is a very sample architecture, very simple, and can be used as a reference architecture for doing something like this. In the connect and collect, as you can see, what we are doing is just collecting basic data from PI server, which is, in our case, it's from this company called OCSoft, but the GE has its own historian, so does Yokogawa, so does Siemens. So a lot of companies have their own historian. In our case, we are using OCSoft. We collect the data from it, we augment data with some of the other data sources, and we run analytics on top of that. So that's the whole connect and collect piece. And at the bottom you see is, once you have that data, you start working with the operational team to define the KPIs. And the KPIs will be then demonstrated on a dashboard with the intent for process and productivity improvements. The process and productivity improvements could be around cost, could be around yield, efficiency, or quality. And if you look at the flow chart on the that side of the screen, connect and collect followed by automated KPI must always follow by continuous improvement, because it's not a one-time exercise. You don't make a factory smart today and you stop. You have to continuously invest technology, methodology, data, and people to continuously improve the level of automation and efficiency that you have in the factory. And the last but the most important point is, of course, around process and people excellence, because all this digitization, connectivity tends to change the way people work. It will affect your process manufacturing processes as well, and that transformation and change management must be handled very efficiently. So with that, let's look at the maintenance use case. So we did the same thing again. We collected the data and then we analyzed the data until we looked at the outcome. So if you look at the bullets below the flow chart, what we did was, in our case, we had SKF, which was one of those handheld devices I was talking about. You go around collecting the parameters of your equipment. And we had what we call the lost cook report. These are lost opportunities in your production cycle due to downtime, equipment downtime. And we started augmenting that data with vibration and maintenance order and notifications. And we were able to then create decision trees and using support vector machine and clustering algorithms to then create some sort of advanced warning signal, some sort of prediction about when an equipment is going to fail. And we were able to do all of this with fairly simple technology. It's actually not very complicated. Where the challenge lies is in bridging the technology with the business process. And in our case, we are process manufacturing. So having that skill set to bridge the gap between process manufacturing and digital technologies, that for us has been the biggest learning. A lot of people can come, especially the vendors, no disrespect to any of these guys who are offering these as solutions, right? But a lot of these vendors will come in and they will talk about how they can do digitization of factories. But the fact is that until and unless they have specific knowledge about your particular process of manufacturing, they will never be able to do a good job out of it. Because that learning process, that discovery process itself is very time consuming. Very simple things can go wrong. For example, in our case, when we were trying to do predictive maintenance, we realized that the time clock of the different equipment that was being measured using sensors was different. It's a very fundamental problem. But because of this, we were not getting synchronized data. And when we looked at the data seemed to be out of sync. And we were not able to figure out why, because everything is working. And it was as rudimentary and as basic as the time clock being out of sync. So these kind of basic problems you will discover and you will understand and you will be able to solve if and only if you have a very good grasp of the business process which is behind what you are trying to digitize. The next use case we have is around kappa number targeting. So just to give you a little bit of background, we are in the pulp and paper manufacturing business. Pulp is a raw material into the paper manufacturing, and the process of producing pulp has a process, right? And that process has a very critical parameter which is called kappa number. And this kappa number is what determines the cost at which that pulp is getting produced. So again, we had to go into the knowledge of how that process is done, and we were able to identify the opportunity to use data to predict that kappa number and minimize the cost, rather than depending on a statistical table which today the operators are referring to. So we can now do dynamic prediction of kappa number compared to a static prediction which the operators were working earlier on. This is in production, and this is during the process of manufacturing. So while the previous use case was around maintenance, this one is around production. And because of this, we are able to generate kappa number alerts in real time. And that has significant upside. It's in millions of dollars, right? What we have done here is we've used some machine learning and AI modeling to achieve that optimization. And the idea is to achieve a stable kappa number rather than the graph which you see on top, right? So with that, eventually it comes down to, for us, very simple QPC, which in the manufacturing world is the most common parameter for measuring KPIs: quality, productivity, and cost. But on a concluding note, what I would like to say is that here we are not talking about automation or making something smart just because there is intent to replace manual labor. No. For us, the primary intent is to drive the cost down in a way where the production is being done using the lowest cost of utilities, lowest cost of chemicals, lowest maintenance cost, and the lowest what we call power cost, right? So it's really not about replacing of people, and therefore in our company, that's the biggest message we drive down to our employees, that AI or automation is not about replacing your job with a machine, but it's about bringing that additional capability which will help you do your job better. So I think with that, I would like to thank you for your time, and me and my team are around if you have any questions. Thank you so much. Have a good morning.